Probably not good. But it was a quiz out of
No,
20.
I didn't get 6 out of
I
10.
know. All right.
I got 80.
So, here's where we're going. We are going to use some more techniques. We're going to do proofs, and they're actually easier than the simplifying, so don't panic. That word would make no. Because simplifying, you didn't know where you were going. Proofs are, I tell you the goal, and then you got to think about, okay, how do I get from here to there? It's actually easier. Can you guys do this warm-up that is using some algebra? So, open a notebook, write these problems down. I want you to factor x to the fourth plus x squared, and x squared minus 1, and x to the fourth minus y to the fourth.
That's
Yes.
how like my kid is multiply the whole tree.
Factoring means unmultiply.
I'm in the city. I give it back to you. So much. I always don't. No, I didn't. You guys did have a pencil piece. I put it on your desk and your desk didn't pick it up. That's on you. I give it back. I said thank you. I literally put it on your desk. I said thank you. Look, you would remember me saying it.
Nick, notebook out. So start by writing down the problem, and then you got, algebra 1 online, that was so.
Alright, I'm gonna take that really quickly. Fernando,
Yes. I don't want
Maura,
to.
Joseph. Alright. William Hershowitz.
That's not you.
No, I was asking.
Okay.
Okay, yeah.
Donovan.
Is it x squared parentheses x squared
Mia.
plus 1? First one.
Maya. Isara.
Yeah, that's my guy.
Senhal.
Well, the second one.
Adam.
Here. I got the or
Peter.
oh, you mentioned.
Vileo.
One.
Gianna.
Here.
Monica. Tycho.
Yeah.
Serene.
Oh, here. Oh.
Alden.
I remember.
Isabel. Jayla. Vivian. Johan.
Actually, I think I can see why.
Will
This
Swan.
is just
Joseph.
Here.
Sarah.
No.
Nick.
No. Here.
Kai.
Okay. Oh, shoot.
Okay, so Nick factored the first one. What's the biggest thing that comes out of both things? He said x squared, and what's left behind is x squared plus 1. Does it factor anymore, or is this done? What do you think? Is it done, or does it go more? Okay, resounding silence. It's done. Van, you said this was easy?
Like easier.
No, harder.
Okay, Van, how do we do that one?
Just did x plus 1 and then x minus 1.
No, she has a
Okay.
Yeah.
Difference of perfect squares. Is the first thing a perfect square? Is the last thing a perfect square? Is the sign between them a minus? Yes? So then square to the first one in the first place, square to the second thing in the second place, and then plus minus. So, Jayla, this one, is this also perfect squares? Do I have a perfect square in the first term? Is x to the fourth a perfect square?
Yeah.
Left code says yes.
Yeah.
Is it like, so if it's something to an even power, it's a perfect square. Is the last one a perfect square? And the sign between them is a minus? Okay, so the process, square the first term. What is the square root of x to the fourth? What is it?
X to the second.
X to the second. So that goes in the first part of each one of these. What goes in the second part of each?
Minus y squared.
Y squared goes in the second part.
Minus 1 plus.
Okay, And it doesn't matter which one, one's minus, one's plus. Is this finished? I sorry, what else do I do?
You can make x squared, x minus x plus.
So I have another difference of squares. So square the first one in the first place, second one in the second place, and again, plus minus. And that one's now done. Okay? So I think this one was to show you, you might need to do more than one step. Okay?
Oh, wait, is the one before your final answer still like, it's correct, but like, would you still?
It's
put
not
that-
finished.
It's not
Wait,
finished.
why don't you do it to the,
Yeah, I
The
was saying,
pluses?
yeah.
Okay,
why is that not more factored than those?
okay.
Working there.
Is that difference
Or
of
is this
perfect
a-
squares? It's not a difference, it was being added, so it
Yeah.
doesn't factor. The homework is out of the textbook, it's at the end of the flip chart, and the online textbook is also on Canvas. Wednesday, a warning, there's an exit card on proving identities. So we just did these. This thing. You guys multiply those out. Again, we're doing this algebra here. X plus y squared. Okay, so, Fernando, how do we do the first one?
Just review, I guess.
Okay, how do we do that?
So you multiply x times x and then x times y and then y times x and then y times y.
Okay, first times first, outside times outside, inside times inside, plus last times last.
X squared plus y
It is not x squared plus y
Oh,
squared.
because adding, my bad.
Because the stuff in the middle, okay? So this is why we did it by the foiling. Adam, how do I FOIL out the A minus B's?
Same thing as the first one,
So we get,
a squared minus ab minus ab plus b squared.
But is it a BA? Or does it
doesn't matter, that's, I was about to ask. He thought about it and was like, nah, I'm gonna say the same thing. 5 times 2 is the same as 2 times 5, and he already had an AB, so let's leave it as an AB because now it's more obviously combined. So this is A squared minus 2AB plus B squared. Okay. This note up here, we're gonna need this with the trig. Conjugates is the other partner in a difference of squares. The conjugate of A plus B, same letters in the same spots, but the opposite sign. So we're gonna use this thing of multiplying by the conjugate to make stuff go away. Any issues, questions? Okay, so that's the fancy word conjugate. Same letters in the same spots, but a different sign in between. Okay. Let's strategies when we're proving stuff. Work on the more complicated sides. This is one of the strategies. Can you write it down? We're gonna do the work on, usually, the more complicated side. Write it down. I write it down anyway.
What are we writing down?
Strategies and hints on how to prove trig identities. We're gonna be doing substitute, like, if you guys are good with algebra, this should be easy. A lot of you have said not a good experience learning this online. So one strategy and simplifying these, it'll make more sense in a minute. We're gonna work on the complicated side.
Whoa.
Maybe we're gonna convert to sine and cosine. Use some Pythagorean identities. Some of you are writing faster than others. Look at all of those things.
Wow.
Combining fractions. What does LCD stand for?
Least common denominator.
Least common denominator, okay.
Greatest.
And greatest common factor, GCF. So the last two are the trickier ones. Factoring, greatest common factor, and that conjugate thing. Got those all written well? Okay. So last week we did simplifying trig identities. This week we're doing proofs, which there was sadness on some faces. So if you guys are still writing, these notes are going to be posted, so you can leave some space and copy them. But I want to try some examples to show you. Write the problem down. And it says, prove this is true. So I need to make one side look like the other. You're not allowed to move things from one side to the other because this equal sign is in question. You need to prove that it's true. Will? Okay, all right, well, so hang on, let's let people write it down. So what side did you start on, the left or the right?
So I wrote tangent as sine over cosine.
Okay.
What I did is I wrote sine is sine over 1, and then secant is 1 over cosine. And so then, because it's sine over 1, the 1's cancel each other out. And it's sine over cosine, which is equal to sine over cosine. So that's kind of like how I proved it.
Okay,
So it is proof.
it is proved.
Is that like how you would do
Okay,
it?
so this is one valid way. Tangent is sine over cosine. He split sine over cosine to be sine times 1 over cosine. 1 over cosine is secant. So we got the right-hand side to look exactly like the left-hand side. This is valid. This is the hard way, in my mind. I would say, so, yeah, Glenn, what would you do?
Here's C cosine is 1 over cosine. Yeah.
And then sine over cosine.
Because tangent and tangent can go out of cosine. Just equal.
Okay, perfect. Okay, so Will saw it easier to start on the right, and my advice is start on the side that looks more complicated to me. The left looked more complicated, but your way was perfect. So you don't have to do these prescribed things. Like the first thing in the hint was start on the more funky, complicated side. Sure. That's what Yuan did, and he got there in 3 steps. So did Will. So you see how this is a tiny bit easier because you have we show you the other side. This is your goal. You cannot multiply things on both sides. You can't add and subtract things left and right. But it's not so bad. All right, try this one. Write this one down. Alvin, which looks like the more
Yo,
complicated side.
that's a little OG.
You broke the trig identities too.
You should have those in your notes.
I'm not trying to go all straight.
Bro, I don't got those in my notes.
I just.
And plus sine.
It's like 10, no. It's 1 plus 10.
But Alvin, which side do you start on, the left or the right? Which looks more complicated?
Oh, I look
The left looks more complicated to me too.
No, right.
Okay, well, we're gonna type this cipher.
Let's do left.
This one.
I hear that.
Okay. Peter, a suggestion on how we would start this. We can't, like, this is in question, so we're not moving things on either side. Strategies were start on the complicated side, which I agree with Alvin. And then they said, look for Pythagorean identities, which are things that have stuff squared. I don't have anything squared. Then there was maybe turn everything into sine and cosine. Can we do that?
I guess we could.
Okay, so cosine is cosine already. What is tangent?
Sine over cosine.
And sine is just sine already, so what is cosine, or cotangent?
Cosine.
Cosine over sine. Okay. Mara, is there anything I can do at this step right now? Cross out the sign. Okay. I don't cross out cosine. Right now, I need to distribute, right?
No, you don't cross out the sign. You have just cosine.
So distributing, you need to give this outside term of cosine to everybody. What is cosine times cosine? Cosine squared. Awesome. Also in proofs, you can't do too many steps at once. You need to show why you got from here to there. Jatavius, what's now? What can I do? Cross out the cosines. And do I have the other side? Yes.
You go to where it's not.
Will, or sorry, Nick, what?
How'd you have to oh, never mind. Never mind. Ah,
Yuan, you still say that starting on the right would have been easier? Like,
you didn't have to do anything to it, right?
I saw it could be one and right at first time, but it's not.
okay, so it's not a sine squared, it was just sine. But, so,
Wait, person.
what?
This next.
Okay. Wow, interesting you say that, because tomorrow are puzzle problems that you guys are gonna do with your partners. Yay! All right.
Whoa.
Whoa.
Whoa. Little OD.
That's what I'm saying, bro.
All right,
What's I forgot that. Is it 1? No, that's plus.
okay, write the problems down, but what is the identity with sine squared and cosine squared?
It's sine squared plus cosine squared equals 1.
Plus. So does this equal 1?
No,
No.
I don't know what it equals.
Well, we're gonna find out.
Um,
So which looks like the more complicated side?
It's the left side.
The ones to the fourths?
Yeah, that's
How am I going to proceed? Isabel got any idea?
I know.
Factor.
Factor it. Great
So,
idea.
Side, it's gonna be sides.
Hold on, shush. Let people think about it first of all. The reason we did the warm up that we did
This
is for this one. Monica, did you write the problem down? Did you write it down?
This very moment.
Gianna, do you remember how to factor this one? No?
I remember.
Heiko?
I think so.
No?
I think I do.
Okay, what is it?
Sine squared theta plus cosine squared theta,
Yeah.
and then sine squared theta minus cosine squared.
Yeah. Okay, Tycho.
Okay, perfect.
That's why he's in the front row.
So
Yeah, that did ring.
this was a perfect squared, that was a perfect squared. Square root of sine to the fourth is sine squared. Goes in the front of each one of those. Cosine to the fourth is square root of cosine to the fourth is
Oh, I got it.
cosine squared in each one. So Alvin, looking up here, is there something that I can use, some identity?
Yes, the sine plus cosine.
It's right here.
It's one.
Oh my goodness. Nick, you gotta calm down. Sine squared plus cosine squared, there's an identity, it's 1.
Yes.
Oh, and then it's just one multiplied that. So
And then it's, then we're done, then we're there, we got it.
Yes.
Not these.
So are these working for you? Okay, yeah, because on the problems on the test, I didn't tell you where you had to go.
Yeah, like I'm kind of messing with this.
I mean, okay. Because when it was just simplified,
Got it. You're there.
I can make that right side look like any number of these. Like I can keep changing it, but then I'm telling you, stop when you get this one. We got there.
She used to do university.
Yeah.
All right. Joey, number 4. How left side or right side? Which one looks more complicated? They both look like stinky.
Right side.
Right side? Okay. What would you do with the right side?
Factor.
Okay, so factor out secant squared. So what's secant to the fourth with secant squared taken out? It is also just secant squared divided, secant to the fourth divided by secant squared. Tavia says is secant squared. And what's secant squared? Melia, what's secant squared taken out? Is it 0 or is it 1? 1. Okay. Now we need to remember that other trig identity that had secant squared in it. Yep. It has tangent in it, but it's 1 plus tangent squared equals secant squared. But then Tycho's ahead of us and he's like looking at that identity. Tangent squared equals secant squared minus 1. So Monica, what can I do right here? That equals to tangent squared? Okay.
Oh my god.
But I don't have this side yet.
Wait. Yeah, wait.
Oh, but wait.
Well, it's in question, but I'm proving it. And okay, hold on.
You can go
So
on.
in high school, we're not gonna be like, prove this, and be like, just kidding, it doesn't work. That's college. We're like, prove this. We think it works. That's getting a PhD, and then you find out you've proven that it's not solvable. And then you got another 4 years for a different dissertation. Yay! But no, we're not gonna lie to you, so it is gonna be true. Yeah, what do you see?
Like if you do tangent squared times tangent squared plus 1, you can change the middle into, so it's tangent times secant, so it's the same.
Okay, well, I somehow need to get rid of to have it look like this side. I have tangents and tangents.
But do you have to, can you change the other side?
You should not. That's like bad form. That's like wearing black socks and sandals at the beach. It's just
Oh,
bad form.
What's
So
wrong
if you
with
do
that?
that, don't.
Oh, they get really hot.
The look is just not there. But I need to get rid of secant squared because I don't have any secants on this side. So what do I replace secant squared with?
1 over
Cosine.
9.
I want to replace it with tangents.
1 plus tangent squared. That's what I said.
Yeah, but look, where does your one come from?
Where does the one come from? The identity itself. The identities that we proved last week.
Oh, man.
So we will give you these identities. You should have them in your notes. But right now, you guys need to look in your notes because I'm not going to write them for you all the time. 1 plus tangent squared equals secant squared. Yeah.
I did it different.
Okay, hold on. So now, multiplying this out, we get tangent squared x plus tangent to the 4th x. It's that thing backwards, but there you go. Tangent to the 4th.
Yay!
Hold on.
I don't understand. Where is the
Okay,
tangent over 4 come from?
are you guys okay that this substitution happened? What does secant squared equal? And why am I using that one? Because there are no secants over here. I need to get rid of secant and secant in terms of tangent.
Yep, and then you
So-
factor.
Now distribute. Tangent squared times 1 plus tangent squared times tangent squared. Okay?
Oh.
Okay, so someone else is saying they did it another way. Would you? Do you start on the left?
I did both sides. I factored both sides.
Okay, only change one side. So if we want to do this side, you said you factored. Then what?
You did the same on the other side.
Can't touch both sides at once.
Oh.
Gotta stay on one side. So tangent squared plus 1 is secant squared.
Yeah.
And this guy is secant squared minus 1. And again, multiplying out. Secant to the 4th minus secant squared.
Yay.
Okay? So you can go either direction. You cannot do both at the same time. Like, it's generally bad form. And you really, really can't multiply something on both sides. Because, again, the question mark, the equal sign is a question. Okay. So, here is a worksheet that we're going to do mostly tomorrow. Please don't lose it between now and then. Okay, one and hand them back. 3.
Not gonna be new.
Okay, who's still missing a worksheet?
Thank you.
Heather got one?
Yeah.
Okay, so the way we're going to like beat you over the head and make you do these. What did we do to go from that first step to the next one? So this side stayed the same, so what happened here to become here?
You factored out the sine squared.
And the next one's the Pythagorean.
Okay, so please write all of this, factored out sine squared x. Factored out sine squared x. So that you see what steps were going on and why.
If I bother you.
Okay, and what did you say?
Pythagorean.
Hey,
Use Pythagorean theorem.
identities, or whatever.
You use the Pythagorean identity, which one? The sine squared plus cosine squared equals 1. And then, Fernando, what did you say you did next?
Yes.
And then we're done, right?
Yep.
Okay. So this is what we're going to be doing tomorrow. We have, the rest of these are tomorrow, but I want to try, hold on, there was one more complicated one. Did it disappear? Oh, where is example 5? Oh, there's example 5. Write this bad boy down.
This, I was confused, you don't take that cross multiplication.
No, you cannot cross multiply. So that's what this one's for. No, that's not today's homework. Today's homework is on the next page that is out of the textbook. That is classwork tomorrow. Don't do any more of it. Yeah.
Where we go forward to?
I don't like that.
Homework is out of the textbook. I'll show it to you in a second. Okay. So there was another strategy on the list today that we talked about using conjugates. And we hadn't mentioned them yet till now. If I want a common denominator, if I want to combine these, like this is one fraction plus another. It somehow mushes together to be one fraction. I need a common denominator. This first guy is missing the plus. You can't just multiply something by a number. If I could, I'd be like, oh, I feel like multiplying my bank account balance by 3. You can't do that. You can only multiply by 1. Will, what were you going to say?
Doesn't, if you put on the left side though, doesn't it still keep it negative? Because it's a negative, not so positive, so it's.
Okay, hold on. So common denominator, this one is missing 1 secant.
Okay.
So we did this as a warm-up, not this exact problem, but if I multiply conjugates together, conjugates are a plus b, a minus b, 1 plus 1 is 1, then, sorry, secant times 1, and 1 times negative secant. These guys go away. Right? So that is the reason that we multiply by conjugates a lot of times, because it's going to make something disappear. So the common denominator is 1 minus secant squared, x. Up top, this is 1 plus secant x plus this one, which is 1 minus secant x. What happens in the numerator? Serene, what happens in this numerator? Right here, these guys. What's 1 plus 1?
Isn't
What's 1 plus 1?
2?
2. What is secant minus secant?
Disappear.
Goes away, right?
Literal.
All right. Pythagorean identity.
It's tangent squared.
1 plus tangent squared equals secant squared. Will says 1 minus secant squared is,
But then it's in the denominator, so shouldn't it be?
okay, 1 minus secant squared.
No. No, yeah, I know
Equals
it's tangent squared, but.
Not tangent squared, but negative tangent squared. I had to subtract it to get to the other side. Okay, I didn't get to the end yet. I have a negative 2.
because tangents in the denominator, that's what come up to the, yeah.
When tangent moves upstairs, it changes name, it's not tangent anymore, it's its co-function, reciprocal function.
You're all into it.
Okay. How y'all doing?
I'm doing great, how are you?
So, for the beginning, can you just like change one minus secant x to like negative tangent x?
No. Why?
Why?
What is the Pythagorean identity?
Oh, it's squared.
Squared. Does a lot. And it is really tempting to say, oh, well, I'm just gonna make that tangent, and then, yeah, it doesn't work out. So they had to be squared. But Adam, they're not so bad because it tells you the other side, it gives you the goal.
Yeah, no, you're good.
Oh no.
So you
All right.
don't-
There's your 6 problems for homework. Can you guys start them?
This pass, yeah.
Like out of here, no, two.
That's so
like
easy.
2 in the numerator.
What?
From the numerator.
There's 6.
Oh,
Like
basic.
homework in general.
We added 1 and 1. I think that's it. And then, oh, secant x minus secant x.
You could get some done right now.
Alright.
Zip that. Dippity that.
Like realistically,
Why
when I
are
go
you
home, I
doing it
just
that way?
Well, then start now.
And then down here, it's just
Why do we like break it apart?
I think because we just brought these up there.
It's the same as,
grow.
it's just like really compound.
I think so.
My best friend. Oh, you have that. Right. This looks clear. No, not yet. I said like.
Okay, guys, get off the phone and start the homework. You have the textbook?